Okay, here's a problem a friend sent me. In the classic movie Star Wars, the hero, Luke, must hit a small target on the Death Star by flying a horizontal distance to reach the target. When the target is sighted, the onboard computer calculates the angle of depression to be 28.0 degrees. If, after 150 kilometers, the target, which has not yet been passed, has an angle of depression of 42.0 degrees, how far is the target from Luke's spacecraft at that instant? So, this appears to be a trigonometry problem. Go ahead and look at it, see how you'd set it up, and then come back and see the solution.
Alright, I guess we can get started with the Death Star problem. Hopefully you would have looked at it and thought of how to set it up, start it, and even a way to solve it. But I began by drawing just a quick diagram. It's not very accurate, not really to scale. So this first position right here, I'm going to label that as point A. That's where Luke starts, and that's where the computer on board on his aircraft says that the target that Luke has to shoot in is located at a 28-degree angle of depression. And an angle of depression is basically you're looking down, and the angle is formed with the horizontal down. And then when Luke moves forward 150 kilometers, I'll name this as point B. When Luke goes forward 150 kilometers, he still has not passed the target, which if you haven't seen the movie, it's in episode 4, A New Hope, the first Star Wars film. It's actually a small hole that Luke has to shoot in, but that target is now sighted at a 42-degree angle of depression. And so what this problem is asking us is to find this distance d, how far away Luke is at point B to the target. So we're basically finding this length right here. So you know two angles, one inside the triangle and one outside the triangle, and you know a length. And so let's start by filling in some extra information that we can know. We can find this angle right here because this is all in a straight line, and 180 degrees makes a straight line. So we can find that by 180 minus 42. That's 138 degrees. That angle has a measure of 138 degrees. Let me fix that. 138. And now we can also find this third angle right here. And that's going to be 138 plus 28, which is, let's see, 138 plus 28 that's a 6, not a 4. 6, 166, and 180 minus 166 will give us the measure of this angle, which is 14 degrees. So, we found all our angles. Let me erase all this junk here so we can have a little more space to work with. And now we can start working with the law of sines. Because we have an angle and the side length opposite it, and what we need is this length right here, which is opposite this 28-degree angle. And for those who don't know, the law of sines states that in a triangle ABC, the sine of angle A over the length of side of A is equal to sine of B over B, and that's equal to the sine of C over C. I'll have to do a proof on that in a later video. This can also be written as, you'll probably see it written also as A sine A over sine A, which is equal to B over sine B, which is equal to C over sine C. That's a lowercase c. It works either way, but I usually use the top way. Because I just like it like that. So, we can use the law of sines. And again, this is for a triangle. I'll draw a generic one right here. For a triangle with angles A, B, and C, that's a B. And sides A, B, and C. Realize that the sides are opposite their respective angles. So, we can start. Let's set up the proportion. Oops, missed a spot. Let's set up our proportions here. We have the sine of 14 degrees over 150 equal to the sine of 28 over d. And d is our distance, the distance from point B to the target, the distance that Luke is from the target. So we go on by solving this. You can cross multiply, so you get d times the sine of 14 degrees. Excuse me. And that's equal to 150 times the sine of 28. You can divide both sides by the sine of 14. And that leaves, since the sine of 14s cancel out, d is approximately equal to, let's get out the calculator. Whoops, almost dropped it. Just so you know, I'm filming this with one hand and doing work with the other. So, let's plug in what we have. Okay, let me clear that junk. So we have 150 times the sine of 28 degrees over the sine of 14 degrees. And I'm going to use the approximately equal sign, since we don't want an exact value, because we're not going to get an exact value, because these values are irrational. So we get 291. I'll go to the nearest whole kilometer. Our answer is 291 kilometers. And that's how far away Luke is at this moment.